So if you stand over this side, it's better because the camera. Okay, so second last talk, Mohammad from IPGP. Go ahead.
Hello, my name is Mohammad. I'm in the second year of PhD in IPG Paris, and I'm working on the OBS data from the Reunion Island. I started with the RAM experiment, which was in 2013, and this is the map of the RAM experiment near the La Reunion Island, near Madagascar. Here is an ocean bottom seismometer, which contains a differential pressure gauge and a seismometer that is broadband. And it's like this one contained, the seismometer here is 1,240,000 that can record the data in the low frequency band. But what I want to do with the data, I will start with the definition of infragravity wave. There are some wind that they generate over the ocean by nonlinear interaction of the wind wave. That wind wave, this is the frequency spectrum, power spectrum density of the pressure, frequency and the amplitude of the pressure gauge. And here is the same power spectral density of the seismometer, pressure gauge and seismometer. These winds penetrate to the ocean floor, and they deform the ocean floor. It's like 10 to the minus 6 meters. It's a micrometer. That deformation is called compliance. That pressure, and okay, we can see that deformation as a peak in the power spectral density of our seismometer. Here I brought an example of the real data that I pre-process to calculate the compliance function. First, I removed the glitches, which is a computer that produces a spike every hour on our data, and it's awful. It's happening every hour, and it's produced a spike, and we can see through the power spectral density. After that, I removed the local and global earthquake, and finally, I correct the data for the tilt effect, which is the effect of the ocean current that it moves the seismometer, and some portion of the horizontal movement is exactly like this. Some portion of the horizontal leaks to the vertical, and in order to see the compliance, we have to remove all of these things. And with that angle that I corrected to bring back the vertical to its original orthogonal position, I found some angles that might, I don't know yet, might define the situation of the ocean current, the direction of the ocean bottom. For the measurement of the compliance, we need just 3 things in the best scenario. This is the power spectral density, frequency, and amplitude. This is the pressure. Infragravity waves start from here, almost. And this is the power spectral density of the vertical acceleration. And this bump is the compliance, this little guy. The relation between these two, this one, is a transfer function between these two multiplied by the coherence. is the compliance in the, and that one normalize the compliance. And with this function, we can calculate the shear velocity of the earth by the inversion method. And this is my first attempt to calculate the shear velocity of the synthetic compliance from this starting model by the Monte Carlo sampling method. I started from the black line and end up to the target model of here. And this is the shear velocity that we can retrieve almost like 20 layers. This one is 11 layer or 12 layer, but I tried for 20 layers up to 14 kilometers or 15 kilometers of the shear velocity. As a conclusion, I have calculated the compliance of 9 broadband stations of the Ram experiment, and calculate the shear velocity of the synthetic model of the synthetic compliance. And thank you.